Hi guys, I'm just done with the assignment to build optimization reg system. So the first step that I did over here, it was to create a data pipeline to ingest the data in a vector database configuration. So I am using this PostgreSQL image that I have pulled, and it is running over here on Docker. It is basically pre-configured with the PgVector extension to store the embeddings. And after that, I'm using text embedding 3 small model for the embedding generation and chunk size for recursive text character text splitter. It is 400 tokens of chunk size and 50 tokens for overlay. So I am just defining the sources over here. From this file there are multiple URLs for each cloud provider, multiple for GCP, multiple for AWS, multiple for Azure, so that I can have great data to store. And after defining the sources, I am using Beautiful Soap to scrape the content from each of the source. And once the sources are scraped, then I am just chunking it using recursive character text splitter technique from LangChain. And then I am here defining the vector store, which is a PgVector, and with opening embeddings model. And then I am directly adding the documents or the embeddings into a vector store to store. So once this pipeline is done, here are the states. So there are total chunks, 93 chunks for AWS, 78 chunks for Azure, and 123 chunks for GCP, and average chunk size is 1506 characters, and the dimension that I am using for embedding model is 1536. Total sources are 23 and document is scrap 21. There is an issue in 2 documents or URLs. So these are the states. And once this pipeline was done, what I did, I created a retrievable pipeline.py file where I have used a ranker model, a re-ranker model, which is a cross encoder MS Marco Mini LM L6 V2 to re-rank the top k values, which retrieval basically retrieve based on the query. So why I define this file, so that I can use it in agent as a tool. So this is the retrieval pipeline, and it is based on similarity search and the re-ranker model. So it will initially do semantic search and it will retrieve 20 documents, and then I am using re-rank. It will then again do a rigorous research or re-rank the retrieved documents, and it will just provide top 5 documents based on the re-ranker. And then once re-rank will done with its search, and then that data will be retrieved, top 5 chunks, and then I am running the retrieval evaluator where I am using Recall and MRR for the evaluations of the chunk, and the states of these are already defined in one of the file over. Let me show you. These are over here. You can see I just tested it on the query that were defined on assignment as a test query. I just use these, and these are the output of the recall and MRR. So let me give it a test on first FastAPI endpoint. I have also created a FastAPI endpoint with the endpoint for query and to check health. This is for query, and then this is for states also, and a rebuild. So it is running over here. Let's follow the link, copy, and I am going to run it over here, docs. So here you can basically query, and so let me test it on this query. Let me execute it. Optimize Google BigQuery storage cost. Let's see the output. So here is an output. In output we are getting the chunks based on the semantic similarity, content, and then the source, provider, URL with confidence score, and then re-rank score. 5 top chunks we are getting. Yeah. So this now same can be tested on yeah, you can also check itself over here. So yeah, pattern 82 and the states, and this same can be tested on LangGraph UI. I have also implemented a LangSmith into it so that we can test our LangGraph also. Yeah, so this is the graph of our agent, and for this in SRC you will be able to see this minimal agent where I am using retrieval pipeline as a tool inside agent, and yeah, you can see over here, and reg prompt is defined or pulled from LangSmith, and you can also see this prompt here as well. And this basically prompt I have defined on LangSmith directly over LangSmith prompt hub. So here this prompt is defined, and I'm then pulling it using LangSmith SDK, and this is the agent structure. Okay, and I am now going to test it on this UI, and I'm enabling this show tool calls and taking optimize Google BigQuery storage cost. So it is using retrieval tool call, retrieving the documents, and here you can see the final output. Thanks. And this LangGraph uses pre-built short-term memory already, so you're welcome. So you can see this output. I have not integrated a long-term memory because it needs a database configuration. It will take more time. So you can see the output, and now here in tracing you guys can see the latency, token cost, and everything. Let me show you. I have a network issue, so therefore there is lag. Yeah, so you can see the latency was 12 seconds because I guess I have a network issue, therefore otherwise it is too fast. And then here is retrieve cloud optimization documents that are being retrieved, semantic search, output, all the documents that are scraped. Rerank. So these are the implementations so far I have done for it. Yeah, there are still few things that need to be adjusted, but for now I will be thankful if you guys will evaluate it. Everything is defined over here on readme file also. I will be looking forward to your feedback. Thank you.